lecture 6 of C++. If you've seen the last lectures, you know I'm stupid, so I forgot to record again. And I'm just gonna do a quick overview of what we did last lecture. If you want more kind of details, I recommend you look in the lecture notes. It should be up by now. Like if you're watching this, you can just go to the Discord channel and take a look at the notes. Okay, so first thing I'm gonna show you this site. This is a really great site right here. It's called Godbolt, or Compiler Explorer rather, and the URL is godbolt.org because it's made by Matt Godbolt. And what it allows us to do is basically it runs, or it compiles our code and runs it, and we can look at the assembly generated. So if I do just if I do just something like int main, like this, and int I equals 5, it'll do nothing, and here we can see the assembly which was generated with 0 optimizations. It's important. So let's get right away. The first thing we're gonna talk about is classes. Classes are declared like this. I'm gonna use a vector, like a vector in maths, to demonstrate this. And a class is like a blueprint for data types. So when I have a class, I then can declare a variable in my code, like a vector v1. But right now it's not gonna do anything because I haven't actually defined anything which it could do in that class definition. So if I want to actually do something, I have to do public, and now I can do stuff. I'm gonna tell you what public means right away. $y. So now we have a vector, and as you know, vectors have like an x and a y component, So what does this public mean? This public means when I'm in here, I can do v1.x equals 5, v1.y equals 1. If I compile this, nothing special happens, which is fine. I don't expect something to happen. If I had private in here, I couldn't do that. It's gonna say something about this member is private, yeah. And so public means everyone can access it in every scope. Private means I can only access it in the class scope, and then there's protected too, which will give us the same error, but protected is a bit special in that derived classes can access variables to derive, like class inheritance and stuff like that. Is reserved for next lecture. So we're just gonna go with public for now, so it's easier for us. It may only look like this vector just holds an x and y, but there's a special thing going on in the background, which you can't see right away, and that is that the compiler actually generates member functions for us. So just quickly, what is a member function? We have like normal functions, like I don't know, like void print std cout hello, yeah. And if I call them in my main, or in anything which is called in main, they're gonna get executed. But what makes member function special is that if I have I just copy this into here, you're gonna see it doesn't work. Why is that? That is because print is a member of vector. So I'm just gonna modify this. I'm gonna do we'll print the where we just can use x and y because we're inside the class, as you can see. So now if I have a vector v1 v1 dot x equals 5, v1 dot y equals 2. Now what I can do is v1 dot print. So what this does is just print 5 and 2, which we'd expect it to do. So member functions. Okay, so when we have a variable of a class type, we call it variable an instance of our class. So v1 is an instance of our vector, and member functions need to be called on an instance, and they can operate with the data inside the class and stuff like that. One exception to this are static functions, static class functions, which we're gonna talk about next time. Today is really just an introduction to classes and to dynamic memory. So one thing which the compiler does for us, which we can do but we don't have to do, is it makes a default constructor. So default constructor just means I can do this, but it also means I can do like 1.0 and 5.0 since those are doubles, and now I can do v1 dot print. If I run this, it'll print 1 and 5. That is because the compiler will add a member function which will look, let me get this straight, something like this. So a constructor now looks like this. It's always the class name without the return type, and you can take whatever arguments you want. And a constructor is special because it's called every time we make a new class. So I can just show you that. Like if I delete this and here I leave that and just add and std cout and constructed and a new line. So if I run this, you'll see constructed. This is because, again, let me just add a new line in here, it's annoying. That is because, as I said, the constructor, or one constructor, because we can have multiple constructors, we can overload them, just as with functions. So the constructor, or the matching constructor to the arguments, will get called every time we make an object. And if I had something like, if I didn't have these in here, I actually wouldn't be able to do this. I'll just show you. Error, no matching initialization of vector. That is because once I have a constructor in here, the compiler will no longer generate another constructor, and the only viable one will be this one. So I have to use it now. So I'll do 1 and 2. Maybe complain, but no, it doesn't complain. But yeah, 1 and 2. And if I just do 0 in here, I don't have to call it explicitly. And if I don't have to do anything in here and just can type this, the constructor is called the default constructor. Now the compiler will actually generate a default destructor too. The destructor is special because it gets called every time a class gets destroyed. Okay, so I'm just gonna show you again. Destructed and a new line. And now if I run this, it'll print constructed 0, 0 destructed. Why did it print destructed? Well, because the vector's lifetime ends here, because it leaves the main function. So its destructor gets automatically called. So we can use the destructor to actually like free data, file handles, and allocated memory and stuff like that. About memory, we're gonna talk about it in more detail in this lecture. Okay, so just to show you the thing with the constructed destructor again, so I'm gonna make a vector v2. I'm just gonna do nothing, but I will make it inside of the scope. So you see constructed twice, constructed, then destructed, because here we leave the scope of we leave this anonymous scope, so vector 2 gets destructed. After we left, there's this print call, and then the vector v1 got destructed. Okay, sorry for the cut. I got distracted by something. Anyway, we left off with the destructor. So that just like shows you what it does in general. There are two other functions which are called, generated by the compiler. One is the assignment operator, and the other is the copy constructor. So we're gonna look at the assignment operator now, and it's like it's not that hard. So if I do this, right, and I will do like 1, 3, and I'll do 2, 5, right? So if I do v2 equals v1, and I do v2 dot print, it's gonna print 1, 3. This structure. Yeah, I'm gonna take this out so it doesn't annoy us. So it'll print 1, 3, and the only thing we have to know now is that basically the compiler generated assignment operator in here will just copy all member variables from one function into from one class into the other, which works fine for this class, but sometimes it doesn't work fine, and that sometimes is gonna get addressed in part in this lecture, but more next lecture. So right, and the last function which gets generated by the compiler is the copy constructor, which constructs an object using another object. So if we do this, it may look like we're assigning objects, but it's not true. Okay, so a vector const vector reference other. Now this is a copy constructor, and now we're gonna do std cout copy constructed, and then of course we're gonna copy the members. Okay, so x equals other dot x, y equals other dot y. And one thing I should mention, this is like the word is a keyword, and it is a pointer to the current instance of our class, which basically means, like, for example, if I have x and y, if I just do x without this keyword, it'll use this x, but if I use this and then x, it'll use our internal x, and we're gonna talk about pointers in this lecture in more detail. So if I run this, it says copy constructed. Why does it say copy constructed? Well, if I just had done this, it wouldn't, and actually it doesn't, because nothing's copy constructed here. But if you use the equals operator for v2 equals v1 in the definition, so if you have a new object and you trying to do object type name equals that object, it'll get copy constructed. So that's something you should know. Right, so one quick mention, well, two quick mentions we're gonna do now is templates and auto. So we can think of classes like blueprints for data types. Like you have an x and y and you have all these functions. This is like a blueprint because you don't actually know what the exact values are when you work with this. Well, right here we have instances of these classes, so we actually know what the exact values are. Right, so let's say you've got a blueprint for a family house, and so this is the blueprint, and this is the actual house, which is gonna have like different colors. Now you can have a blueprint of a blueprint, so to speak, and those are template classes. And it maybe sound a bit hard, but it's actually really easy. In the case of class, we just do template, type name t, or you can use class t. But type name is better usually because it's more precise, and we don't have to have two classes in here in the declaration. So, and by the way, I forgot to mention, everything is private by default. So if I do like double z, it's not gonna compile anyway right now, but if I do this and then would try to access z in here, it would say it's private. So that's one thing to know. So if I basically changed nothing about this, but I added a template, and now it won't work. Yes, and it doesn't work because let's see, is it 10? Yeah, and it doesn't work because we don't actually work with a blueprint right now. We're working with a blueprint of a blueprint. So if you want a blueprint, it's actually pretty easy. We just do here these angled brackets, and we'll do a type name as you said in here. So I do like, I'm gonna just do the second part here wouldn't be required in the newest version of C++, but we're just gonna do it. I think it wouldn't be. I haven't tested it. Okay, so now it runs fine, but it doesn't actually do anything because we just added this in here and didn't change anything. But now we can do, instead of using any specific type, we can do that here. We can just use this t, and now what it does. Sorry for the noise. What it does is that instead of having one fixed type, we can use every type we want. So one useful, like, sometimes you want to work with doubles, but sometimes it would be nice to have just a vector, or a vector in this case, like this class is more like a pair of two numbers. Sometimes you'd like an int, not a double, just an int, and then you can just do int in there, and it will work perfectly again. Yeah, Replit is a bit buggy. Now it's fixed. Okay. I could actually do float in here too if I wanted. So basically you can do any type in here, and it's gonna work more or less. But you gotta watch out if I like, for example, had a sum, like a t sum. So what this t sum means, it will return the type t, and I'll do return x plus y, and now I'm gonna do std cout v2 dot sum, and I'm gonna delete this so it doesn't bother us anymore. Right, so if I run this, it'll say 4, right? But you have to watch out, because if you do something like this, you basically have to assume that you can add these two things, and you're like, oh, of course I can add two numbers. Well, but as I said, we really could use any type in the template thingy in here. It's actually called template parameter list. But if you do a std vector int, so it's not our vector, it's the std vector, and std vector int in here too, it's not really gonna work, right? We have a bunch of these really ugly errors, like even for Clang, really ugly errors. And the first one is in here because this isn't a vector, and if I just think even default constructing it won't work. So this is just now a complete mess, right? In C++ 20, which isn't released yet, we're gonna get a thing called contracts, where you basically can say, like, I only want types which I can add, or which I can sum, or which I can do whatever I want with, which I specify. But in today's newest version, which is 17, you have to watch out for this. And if you are not careful, you're gonna get these like awful walls of errors. That's the thing I wanted to say about templates. And now I wanna talk about auto a bit. Okay, so auto is a keyword, or yeah, it's a keyword. If I auto t equals 1, and what auto means, basically it says the type of this t is whatever type this is, and 1 is an int, so t is gonna be int, right? So I can do if type ID is just it's some number basically, which says that's a type, which represents the type for the compiler or something. So I have to if the type ID of int equals type ID t. So this says this basically says if t is an int, I'm gonna do std cout is. So and it's gonna print that. If I do 1.0, on the other hand, it's not gonna. For it to print, I would have to do double in here. So and it is now. So auto just makes our life easier, and in the intermediate, no, in the, I think I'm gonna say that for the advanced, in the advanced lecture series, which is going to be coming up soon, we're actually gonna learn a bit about generic programming, and we can use auto there quite effectively. But for now, all you really need to know is that auto makes our life easier because it can deduce types. And by the way, auto works for really anything. Like if I do a stud vector and 1, 2, 3. Like in I don't have to do an int in here in the used version of C++, which is 17, and it'll work, right? So auto makes our life easier. That's the point of this whole thing. Next thing, the stack and the heap and the CPU. I'm just gonna show you. I'm just gonna talk briefly about it. But I think my mistake in the actual live lecture was that I got too technical and just people lost interest after a while. So, this is a nice image. Basically, when a program starts, it's gonna get loaded into RAM, and like a small chunk of memory is gonna get allocated, which is called the stack. And if I move into here into the assembly output, then RSP is the stack pointer, which means it always points to the highest place in the stack. So what I'm gonna do is, I'm just gonna show you this size of int, and I have to include IOStream, of course. So size of, what size of does is it tells us the size in bytes of a data type. So int is 4. That's fairly basic. Like integers are 32-bit on most platforms, and 1 byte is 8-bit. On 99.99999% of platforms, 1 byte is 8-bit. If 1 byte isn't 8-bit on some weird platform, please tell me, because I don't know of any. So anyway, now we know that an integer has size 4 bytes. And now if you look at the assembly, you can see that RBP, we copy the RSP into RBP. So RBP is now the same as RSP for our purposes. Now we see RSP minus 4, 5. So it's gonna take a small here, it's gonna take 4 bytes of this, and this is our I. A small chunk in here, this small 4 bytes in here are our I, and we can see move the word pointer RBP minus 4 and 5 into it. Okay. If I do an array, because arrays are stack based too, int array 5 and 1, 2, 3, 4, 5, you're gonna see it's gonna do the same thing basically, and it's gonna allocate a bunch of memory on the stack. And that's fine. The stack is really fast, but we can run out of space on the stack, because you see it grows, and once it exceeds its size, you're gonna get a stack overflow. So if I'll do a really big number in here, it's not gonna like it. I think I have to actually initialize it to something. Yeah, 135 here. It's not 0 anymore. So, or I can do it in here, so we'll get the nice error messages. So int array something. I don't think the declaration itself should do anything. Yeah, but okay, it does. So exited segmentation fault. We see that these, what is it, 5 million or 500 million integers. That's a lot. That's a big chunk of memory. 500 okay, 5 0 0 0 0 0 0 0 0 times 4. This is the amount of bytes, right? And we're gonna 1 2 4. These are megabytes, and 1 2 4 kilobytes. So these are megabytes, and we can see it's something like 2 gigabytes. Oh, and the stack is more like 2 megabytes. So like we exceeded the stack by like a factor of 1000 or something, which obviously doesn't work. So segmentation fault in here, but more specifically stack overflow. Now we're gonna talk about pointers. So what are pointers? For any data type, there can be a pointer to a data type. So I'm just going to use int, and it looks like this. So ptr is a pointer. What does that mean? What is a pointer? Okay, if I have a variable like int j equals 5, what I can do is I can assign that pointer to at j. Okay, now if I still see out the pointer, what you'll see is an address in memory. Like if I do just RAM in here, something like RAM layout. Basically, it's gonna use something like this. Basically, in our RAM, there are these offsets of it starts at 0 and it grows. And this address is like the specific place in memory where the variable is at, and that place in memory is gonna change. So if I run this again, you have to look at the last 4 or 3 numbers. They're gonna change all the time. So yeah, it changes. Which shows us that each time we run this, there's a new place in memory which we'll get, which is absolutely fine, and it's normal. Like if you get the same places in memory on like a normal PC in quotes, because if a normal PC does this, it's not normal anymore. Right, but what do pointers allow us to do? So in C, you use pointers instead of references. So anytime you wanted a reference, you could get a pointer. And that is because once you have a point, actually I didn't actually want to do that really. That is because actually once you got the pointer, you can access the value at that pointer. So cout here. This star means value of, or value at the address of ptr. So we'll get 5, and I actually can do. And now I'll just show you that this works like a reference. Like if I do this, it'll print 2, and if I change it yet again to 4, like this, so I can change it like this, we'll get 4 again. No, not again. We'll get 4 as in here. So like in old code, people used to use pointers instead of references. Another useful thing for you can do with pointers is, for example, if I have an array, int array 5 equals 1 2 3 4 5. You can do pointer arithmetics, it's called. So for int I equals 0, I over 5, I plus plus. Okay. So we're gonna iterate over that array, but before we do that, int pointer equals array. It is because if you do array without any like without any like this, it means give me the pointer to the first value in here. And if I'm gonna print the address of each. So that is ptr plus I. And what you'll see now is that here, oh, I'll do spaces in between, because else it's not really manageable to read. Okay, so now you see 740, 744, 748, 740C. It's because it's hexadecimal again. But the point is they differ by 4. And what do you know about ints? Ints have size of 4. So this tells us that this array is contiguous in memory. So one spot under the first element is the second element, and right on. So we can use pointer arithmetics like this, and if I do this, it'll just print the values. I'm first gonna copy it. Now if instead of printing, I might assign something like 0 to that, and now I'm gonna print it again. It'll print 0 5 times. Yeah. So those are like the basics of pointers, like how they work semantically. And now we're gonna actually get to something called dynamic memory, because like oftentimes you're gonna need to work with more than just the 2 megabytes you can have on the stack. Like just ask on our Reddit, there's this guy C++ORNO. He used to call himself Corno. And like he in his work has like multiple gigabytes of data he needs to put in RAM. And how do we do that? How do we put things in RAM? So in C++ we're using new to get something. Okay, so if I do int, it's new int. That places that int somewhere in RAM, and we get just a pointer to that specific place in RAM. Why don't we do this all the time? Like, first of all, it's ugly. Like, pointers are not the nicest thing to look at, really. And second of all, it's way slower than the stack. So single allocations like these usually don't make much sense, but we can still work with it, like at I equals 5, std cout I, and then the value of I. Just see it working. I think it's kidding me. Oh yeah, now it works. So here's the address, here's the value. If I'm gonna run this again and again, you can see like the address changes. Does it? Yeah, it does. Yeah, but the value doesn't, because the value is always 5. So, what's the drawback to this? Like, of course, speed. And the other thing is, like here in main, the memory automatically gets deleted once I'll end this. But actually, most of the times you won't do this. Most of the time, like not most of the time, anytime you use new, you have to delete after it. So you do delete I. If you don't delete I, you're gonna cause a memory leak. What is a memory leak? So a memory leak means you leak memory. And what does it mean to leak memory? Well, it means you occupy stuff in RAM. So for this is like it's just 4 bytes. But like again, if you have a server and this happens several times a minute and it runs for days, it's just gonna go bigger and bigger, and then it's gonna crash. So memory leaks are no good. And actually we're gonna spend the last part of this lecture on talking about why we don't use raw new and delete like this. But to get to the point, if you don't delete something, the computer will think you still use that thing, and your RAM is just gonna go small. It's gonna go smaller and smaller and smaller, and or the free RAM goes smaller and smaller and smaller, and then your computer's just gonna crash or get really slow when you really don't have any RAM anymore. Next thing, a far more useful thing than that, than just a single int, is you can allocate dynamic arrays. So which means, yeah, I'm gonna ignore it for now. Well, I'm gonna do 10, but you can do really any size that fits in RAM. So now I have in memory, one after the other, 10 ints, which is 40 bytes in total. So, and now I can just still have the for loop copy. No, I haven't. Okay, so I have to type it. Yeah, so for int j this time, because we already have I. 0 j over 10 j plus plus, and now we'll do I plus j equals j. So it's gonna be 0, 1, 2, 3, 4, yada yada. Oh yeah, of course. You value there, not the address itself. We can't change that. And now I'm gonna do the same but print it just to show you. Okay. And std cout. Okay, it's gonna print 0 to 39. Right. So the advantage of this is you can actually, like in C++, not in C, but in C++, you can have only, if you have normal arrays like this, like the size of that has to be compile time known, which means you can't dynamically resize stuff and so on. And this new allows you to have dynamically sized memory. And later you're gonna see you stood vector used a lot, and stood vector int yada yada. And another thing about vectors is you can resize them, and that is because a vector just wraps this whole concept of dynamical memory yada yada, and yeah, and we don't have to deal with that. And another thing is, every time you allocate with these brackets, you have a dynamic array, not just one value, you have to call delete like this. So delete I. That is because if you allocate more than one, it's usually gonna put the number of how many things there are in the array at the beginning in memory, and then all the stuff you have to allocate. So if you do a delete like this, a delete like this of just one, it's not gonna work really. The behavior is undefined, and practically it's not gonna work. So that is delete and new. And now we're gonna go to why we don't use them. So C++ introduces exceptions. What are exceptions? They are supposed to be exceptional events. And I might just show you a piece of code which is not memory safe, which actually leaks memory. And just imagine this is some part of another big software, and it's not just in the main. Okay, so if I have a std vector int I. Also, I have a pointer, a vector of pointers to int. Okay. For auto reference, I'm just gonna call this vec for vector. Auto I in vec, and we already know what this means. This means for every element in vector, and we're gonna auto in this case is int pointer, and reference means that we get the actual value, not a copy. We're gonna do I equals new int. Okay, and like for example, if this is really like we don't have to use this. This doesn't really make sense because vector itself already allocates stuff we put in here in RAM. So if we just do vector int, it'd be perfect. But let's just say for some reason we need to do this, or we want maybe some like dynamic things. But again, you could have a vector of vectors. Well, let's just say we need to use this somehow for some reason. And what we'll do now, like we can work with this, like auto reference I in vec the value at I equals, I don't know, 4, and then we can, oh yeah, and I should have given it a size, my bad. So I'm gonna just do 10 again, and here I'm just gonna do same once again, auto reference I vector, and I'm gonna std cout. No, this time for my example to work, I need to do it this way. Int I equals 5. Sorry, I haven't slept much. For int I equals 0, I vector dot size. That's a nice thing about vectors too. You can get the size like this I plus plus. Now I'm gonna do this because yeah, because that's a mistake. That's a mistake I have done, and I know of it. So this is these are pointers. So I'm gonna just std cout this. Now it's gonna print. It's not gonna actually print anything. It's segfaulted, and wanted it to throw an exception. I wanted it to throw an exception, but yeah, because I'm gonna print these addresses, and it doesn't do what I wanted to do. But basically, if you do something like this, and then we're just gonna do if, let's do new lines in here. So at least looks nice. So yeah, 0 in here. So it at least looks nice. Oh, I have to do at. Now I know why. Yeah, sorry. Do at here. Okay. So and now after I'm done with that, I'm gonna go for auto reference I in vec, and I'm gonna delete all of the memory I did, right? Because like I'm smart. I'm gonna delete I. So I'll run this, and it's gonna throw an exception now. I'm so used just to do the brackets in here. So yeah, if you use at, it's replit. Fucking with me again. Yeah. terminate call after exception. Okay. You'd think this, okay. That's not that bad. But, what happens if an exception is thrown, it is just gonna jump out of the function right then and there. Which means that delete in here never gets called. Never. Like delete it's into memory, and we're gonna leak memory, and like all programs at some level will deal with exceptions. So this exception is gonna get caught somewhere, and the program will usually just resume. Okay, it happened. What do I do about it? Not much really. I'm just gonna run. But now we leaked memory, and in this case we leaked like 40 bytes. But 40 bytes, like, that can grow. Like 40 bytes, if you do this like 12 times, if you do this like every 5 seconds, if you have a big server and this happens every 5 seconds, times 40, and you run it an hour and a day, how much is that? It's already 690 kilobytes, something. And if you run this for multiple days, you're gonna get more and more, and then it's gonna crash because your RAM is full. Yeah. So that is why we actually don't like to use this new and delete by itself. I'm gonna show you. Like I'm gonna make a class, because one thing delete does is that it calls the destructor. And I'm gonna make a class X, and I'm gonna delete this because I just want this example. Class X public X. Okay, so cout destructed, and now I'm gonna do this, and this is a pointer to the current instance. So we're gonna get the address of the current instance, and I also want the constructor x cout constructed. This and new line. Okay, I'm gonna fix this error real quick, and I'll do new x, and here x pointer. I'm gonna run this, and yeah, here it constructs it all, here it prints it all, and here it deletes it all. Fine, right? But now, if I do this, no destructor is called. Memory leak at our hands. Bad. Really bad. Now you might think, okay, I'm just not gonna use new. Which is right, but what do you use then? You use smart pointers. Include memo. Spelling is hard, isn't it? Include memory. Okay. And instead of raw pointers, use shared ptr or unique spelling is hard ptr. And these both are smart pointers. We call them smart because what they do is, once they get destructed, which means they leave scope or something, they are gonna delete the memory they point to. Unique pointer works in a way that always when it gets destructed, it's gonna delete the memory, and you can't really copy a unique pointer. You can't, and if you like, you can only move assign it. So So basically there can only be one unique pointer pointing to something at once. And a shared pointer works like that it has a counter of how many shared pointers point to the same thing. And once a shared pointer gets deleted and there are no other pointers remaining to that thing in memory, it's gonna delete it. So if we replace this with stud shared ptr x, we don't do x pointer, we can just use x, and think doesn't work. Oh yeah, so what we have to do is to do, why doesn't it work there? Yeah, I think this okay, so I went to look it up. Replit fucked me hard. I lost everything I did, so this is completely new. Some errors showed up, so yeah, while I was doing this. So basically, if we have a shared pointer, if you have shared pointers and you want to assign them, we don't use any like trickery and stuff like that. The best thing, and which you should always use, is stud make shared or stud make unique. But this is not a unique pointer, so you're just gonna use stud shared, make shared. And if your constructor would need any arguments, you'd put them in here. Yeah, that's basically it. Sometimes with complicated stuff, it could happen that you pass new as an argument to a constructor of a shared pointer, and like in the same expression, you'd also call a function which would throw an exception, and that's like, it's like really corner stuff. But theoretically, you could have memory leaks through that, so it's always best to use stud make shared and stud make unique when you use smart pointers. And this rest here, it just prints the pointer which is stored in the shared pointer. If you need a raw pointer, use .get. But watch out, if you use .get, know why you use it and be smart about it. Okay, if I run this, we'll go construct it, then it says, and it destructs. Isn't that nice? It destructed automatically. I think that's really nice, and in fact it's the whole point of smart pointers. That once we leave main scope, stud vector gets destroyed, and stud vector, when it gets destroyed, it will destroy all of the things which are in it. And when a shared pointer gets destroyed, it will delete the pointer it points to. So we get this. And that is the end for the class. I hope you enjoyed it. I think there's gonna be some homework, probably.